In this video, I want to introduce you to triangular numbers. Now, you'll have a little bit of a lead-in if you've ever played pool or snooker, and you think about how the balls are first placed onto the table in that triangle. Okay, so in snooker, on a snooker table, you have a triangle that you place the balls into to get them into the correct position. And imagine that you are placing the balls in row by row. So the first ball that you would place into that triangle would position it right at the top. And then to get the next row, you'd have to put two more in. So we would have two balls placed in then. And then if we place the next row in, there would be three balls below that. So we've got the three that's already there. And then we're going to add in another three, a row of three. And then the next row will have four. So we'd have 1, 2, 3. So we've got a row of four. And then the final row would go in, and that's 5. Okay, so on a snooker table, that would be your lot. If you don't know what I'm talking about with snooker tables and things like that, and you've never played it, don't worry. Because essentially what this is then constructed is the first 5 triangular numbers. So triangular numbers as a sequence is the number of dots that you have here. So it goes 1, then 1, 2, 3, then 1, 2, 3, 4, 5, 6. Okay, so by this point, rather than counting the dots, we can go, well, what's happening? To get from 1 to 3, we add on 2. And then to get from 3 to 6, we add on 3. Okay, and then we're adding on this next row, aren't we, which has 4 in it. So we're adding on 4 to the next one. So that's going to get us to 10. And then to get the next row, we're going to have to add on 5. So that's going to get us to 15. So there are 15 reds on a snooker table, because that's the number that you can position in to the triangle. And so the next number in the list would be 21, okay, because we would add 6 onto 15. And so these are the triangular numbers. Now, a couple of things to go with that. You might be asked to work with a sequence that is similar to the triangular numbers. So it could be a sequence where rather than you're adding 1 to the difference each time, it could be that you're adding on 2 to the difference each time, for example. So you could have something like starting with 1, and then we add 2 to get the next term, so to get 3, but then we add 4. So to get 7, and then we're going to add 6 to get 13. And then we could add 8 to get 21. So you could have a sequence like this, where it has a similar sequence, and you just need to identify really what's going on. So that's one thing. There is an nth term for the triangular numbers, and it's given by a quadratic nth term. And that is 1/2 n plus 1. So this is the nth term for the triangular numbers. So let's say we wanted to work out what the 6th term was. Now we know that the 6th term, I would need to add 6 onto 15, so we would get to 21. So if n is 6, we would have 1/2 times 6 times 6 plus 1, so 7. So 1/2 times 6 is 3, and 3 times 7 is 21, as we expected it to be. So this is the nth term. Now, I would probably say that, particularly if you're doing higher, this would be a good one to learn, okay? To know that that is the nth term for triangular numbers, okay? But this is your introduction to it. It could be done in a diagram kind of way, or it could be with the numbers themselves, but you do need to know your triangular numbers and how to generate them. Okay, so the diagram should help with that.